Algebra 2, Chapter 12, Section 7, Graphing Trigonometric Functions. So, right now we're going to have just two main descriptions of circular functions. The first one we talked about in the previous lesson, that would be periods, or how long it takes for the domain, or inside the domain, for one complete cycle, as a graph, to complete. And then the second part is something we call amplitude, which is basically the minimum and maximum of a cycle. We kind of talked about it a little bit yesterday, or at least I showed you the graphs where you can kind of see for the base functions or the parent functions of sine and cosine, uh, the amplitude is 1 because the absolute value of like the distance between the top and the bottom is 1. Or like it's not 1. It's like from the center line to the top is 1. From center line to the bottom is 1. So we call the amplitude 1. Um, but it's describing the minimum and maximum of the function. Just like yesterday, you may have noticed that for the sine function, it has a period of 360 degrees. Same for cosine. They both have an amplitude of 1. Domain is all real numbers, though a big thing here is how you can kind of tell them apart is the sine function starts at the origin, and the cosine function starts at the maximum for their periods. So that's what we're going to work with. Now, there are some very basic transformations that change the period and the uh, amplitude for these parent functions. I'll show you sine. We usually have some number that's being multiplied by the function itself. That is going to affect the amplitude, right? So all you have to do to calculate the amplitude is just figure out what the absolute value of that whatever is being multiplied by the function to take as the absolute value. Uh, for the second part, you can see we have a number being multiplied by the input, and we don't write it here, but it's the sine is a function. So whatever angle you're putting in, you're multiplying it by this value b, and that is actually going to determine the period. And if you're using degrees, so for degrees, you would have 360 divided by the absolute value of that, and it would give you the period. If you're using radians, you just swap out the 360 for 2 pi over the absolute value of the b. All right, that's pretty consistent throughout everything. Whatever the period is, if the period's 360, that means in radians it's 2 pi. Okay. All right. Now let's go ahead and actually use this a little bit here by describing the amplitude and period of this function. And our directions are to find the amplitude and period of y equals cosine of 3 theta. Well, I did sine before, but cosine's the same way. It's y equals the amplitude times the cosine of the thing that adjusts the period times the input. Um, so here's the idea. That a value is 4. So the absolute value of 4 equals 4. So that is the amplitude. 4. And if you look on the graph here, you can see that 4 is the maximum and negative 4 is the the minimum. That's how we describe the amplitude. The other one we were looking at is the number getting multiplied by the input. In this case, that is 3. Oh, I wrote 3 in both of them. It's supposed to be b up here in the top for the general form. All right. So, and if we take a look here, we can see on our graph that this is described in degrees. So we're going to continue using degrees. 360 divided by the absolute value of 3, and we can see that is 360 divided by 3, or 120. So now I'm going to say the period is 120 degrees. So basically that means in 120 degrees a complete cycle should take place. And if I were to sketch that out on my graph, you would see I start at the top like cosine does. I come down and I come back up, and I'm not the whole way up yet. I'm already at 90, and you can see right there at the top that looks like it's about 120. So there you go. That is the amplitude and period. Pretty, not too rough of a calculation.